in cells? Cytokine. What do you call any chemical messenger that's released by cells and allows for communication? Cytokines. Are interferons a type of cytokine? Yes. Are interferons a type of cytokine? Yes. What's the function of interferons? They interfere with viral replication. So what's responsible for blocking viral replication? Interferons. What's responsible for interfering with viral replication? Interferons. Do interferons prevent viral replication in our own cells? Yes. Are they naturally produced by our own body? Yes. Are interferons produced by our own body? Yes. Are they chemicals or cells? They're chemicals. Are the interferons chemicals or cells? Chemicals. So what do we call a chemical produced by our cells of our own body that block viral replication? Interferons. Complement is a series of 20 proteins. How many proteins? 20. How many proteins? 20. What organ produces complement? Liver. What organ produces complement? Liver. Does it cause cell lysis? Yes. Does it enhance phagocytosis? Yes. Does it enhance inflammation? Yes. Does it increase phagocytosis? Yes. Does it increase inflammation? Yes. Does it cause cell lysis, phagocytosis, and inflammation? Yes. What's another word for enhancing phagocytosis? Opsonization. What's another word for enhancing phagocytosis? Opsonization. What's another word for opsonization? Enhancing phagocytosis. What are the three functions of complement? Cell lysis, enhancing phagocytosis, and enhancing inflammation. Okay? Is cytokines, actually here's a good question, are cytokines, complement, and inflammation all part of innate or adaptive immunity? Innate. They're all part of innate. Inflammation is a localized tissue response to injury. True or false? True. What do we call a localized tissue response to injury? Inflammation. How many cardinal signs of inflammation are there? 4. How many cardinal signs are there? 4. What's the word for redness? Rubor. What's the word for swelling? Tumor. What's the word for heat? Calor. What's the word for pain? Dolor. What's the word for redness? Rubor. What's the word for swelling? Tumor. What's the word for redness? Rubor. What's the word for swelling? Tumor. What's the word for heat? Calor. What's the word for redness? Rubor. What's the word for redness? Rubor. What's the word for swelling? Tumor. What's the word for swelling? Tumor. What's the word for heat? Calor. What's the word for pain? Dolor. Okay. What do you call dead tissue? Necrotic. What is local tissue destruction? What do we call dead and dying neutrophils? Pus. What do we call dead and dying neutrophils? Pus. I'm not going to ask about an abscess. Fever is caused by what chemicals? Pyrogens. Fever is caused by what chemical? Pyrogens. Do bacteria produce pyrogens? Yes. Do our cells produce pyrogens? Yes. What part of the brain has receptors for pyrogens that actually increase body temperature? Hypothalamus. So does the hypothalamus increase body temperature? Yes. Can the hypothalamus increase body temperature? Yes. Can pyrogens tell the hypothalamus to increase temperature? Yes. When pyrogens are activated, can they cause fever? Yes. Is fever part of innate or adaptive? Innate. Okay. Does fever increase the metabolic activity of our cell? Yes. Does it inhibit some bacteria and viruses? Yes. Okay, we've talked about cell-mediated and humoral immunity already. This is all part of adaptive, also known as acquired, also known as specific immunity. Okay, from here down. So cell-mediated is T cells or B cells? T. Cell-mediated T cells or B cells? T. Antibody-mediated is also known as humoral. And actually I prefer the word humoral. But humoral, does that involve B cells? Yes. Does humoral involve B cells? Yes. B cells become what type of cells, guys? Plasma cells. And plasma cells secrete what? Antibodies. What do plasma cells secrete? Antibodies. What is another word for antibody? Immunoglobulin. What's another word for immunoglobulin? Antibody. What's another word for immunoglobulin? Antibody. What's another word for antibody? Immunoglobulin. Cell-mediated is T or B? T. Cell-mediated, T. Cell-mediated, T. 5 more times. Cell-mediated, T. Cell-mediated, T. Cell-mediated, T. Cell-mediated, T. Cell-mediated, T. Humoral. 5 times. B. Humoral, B. Humoral, B. Humoral, B. Humoral, B. So what is B? Humoral. What is T? Cell-mediated. What do plasma cells produce? Antibodies. Are antibodies cells or proteins? Proteins. Okay. Do lymphocytes have the ability to produce clones? Yes. Do lymphocytes have the ability to produce clones? Yes. Okay. Next, innate. Are you born with it? Or is it something you develop after you're born with it? You're born with it. Innate means you're what? Born with it. Innate means you're what? Born with it. Is skin part of the innate or the innate system? Innate. What about complement? Innate. What about inflammation? Innate. What about fever? Innate. Okay? Remember, they're not specific against a particular bacteria. What about T cells and B cells? Adaptive. What about T and B? Adaptive. What about T and B? Adaptive. Okay? Is it adaptive also known as acquired? Yes. Is adaptive also known as acquired? Yes. Okay. Are T cells and B cells specific? Yes. Are T cells and B cells specific? Yes. Are they versatile and have the ability to attack multiple antigens? Yes. Do T cells and B cells have the ability to produce memory cells? Yes. Do T cells and B cells have the ability to produce memory cells? Yes. Now, tolerance. Does that mean it tolerates bacteria? Hold on. Tolerance. Does that mean it tolerates everything or just our own cells? Our own cells. Our own normal cells. So tolerance means that our T and B cells tolerate, they ignore our normal cells. Okay? So what happens is like T cells and B cells go around and look at all our cells and goes, oh, you look like a normal cell, you look like a normal cell, you look like a normal cell. And then all of a sudden it gets to a cell, one of our cells, the T cells and B cells get to one of our cells and looks at it and is like, wait a second, there's something wrong with you. Then what happens is, then our T cells and B cells kill it. But in general, do T cells and B cells display tolerance? Yes. Now, antigen-presenting cells, okay? Almost every cell can serve as an antigen-presenting cell, okay? But when they serve as an antigen-presenting cell, what is the structure, or what is the protein, I could say it either way, what is the structure, what is the protein that is responsible for presenting the antigen? And the answer is MHC. So what's responsible for presenting? Remember we had this picture? We talked about this in a previous lecture. It's actually down here on the bottom right in that picture that we have down there. Okay, what is the name of the structure that presents the foreign antigen? The foreign antigen's in red, so this structure right here that's presenting it is called MHC. Do antigen-presenting cells have MHCs? Yes. Do antigen-presenting cells have MHCs? Yes. Do MHCs present the foreign antigen, which is in red? Yes. Does it present it to T cells and B cells? Yes. They present it to T and B cells. Okay? It tells the T and B cells that this red thing, the red antigen, is what they need to look for when they go out and they start hunting for other antigens. They're looking for other antigens like that. Okay? Now, how many classes of MHC do we have? 2. How many classes of MHC do we have? 2. How many classes do we have? 2. MHC1 is found on all nucleated cells. So in other words, they're found on all cells except what? Red blood cells. They're found in all cells except what? red blood cells. So, do your epithelial cells have class 1? Yes. By the way, class 1 stands for what? MHC1. And I'll put this version of it more than this. I mean, I may write that down, but I prefer MHC1. Okay? So do, I don't know, epithelial cells have MHC1? Yes. Do all nucleated cells have MHC1? Yes. Do liver cells have MHC1? Yes. Do kidney cells have MHC1? Yes. Okay? And does MHC1 present? And the answer is what? Yes. Class 2, or MHC2, is found on the membranes of lymphocytes and what we call antigen-presenting cells. So is class 2 found on antigen-presenting cells such as macrophages? And the answer is yes. So that's the key one. You want to remember macrophages. So MHC2 is found on what? Macrophages. MHC2 is found on what? Macrophages. What is MHC2 found on? Macrophages. Okay. Are CD markers... Oops, sorry guys. What do we call the structures on the surface of the cell that identify the cell? CD markers. What do we call the antigens on the surface of our cells that identify the cell? CD markers. Okay, so the big thing you want to remember is CD. So what are the antigens? So if, let's say this is one of our cell, and this is an antigen on the surface of the cell. Is that a CD marker? Yes. Let's say you had another one like that. Is that a CD marker? Yes. So I don't care about CD3, but I want you to remember CD8. CD8 markers are found on cytotoxic T cells. Okay, so CD8 is found on what? Cytotoxic T cells. Okay? So cytotoxic T cells have an 8 as an antigen. CD4 are found on T helper cells. So I'm going to put a 4 there. Okay? And that's the difference between the two. Now, another way of saying another way of saying cytotoxic T cells is CD8. So if you see cytotoxic T, you know it's what? CD8. Cytotoxic T cell, CD8. Cytotoxic T cell, CD8. T helper cell, CD4. T helper cell, CD4. T helper cell, CD4. Okay? Okay. Are there such things as memory TC cells? Yes. Are there such things as memory T cells? Don't even worry about the TC. Are there such things as memory T cells? Yes. Do they make it easier and faster for our body to fight the second time it comes down with the same infection? Yes. So if I said something to you along the lines of, what cell is responsible for ensuring a rapid response for the second time you come down with an infection? The answer would be what? Memory T cells. If I said to you, what cell is responsible for responding quickly to a secondary infection, your answer is what? Memory T cells. Okay? If I said to you, what cell will inhibit T and B cells once the infection has been resolved, the answer is regulatory T cells. So once the infection has been resolved and you don't need T and B cells anymore, regulatory T cells tell the T and B cells to relax. Regulatory T cells say what? Stop. The infection's been cleared. So what cell is responsible for saying stop, the infection's been cleared? Regulatory T cells. What cell is responsible for becoming active when the infection's been cleared? Regulatory T cells. What is the function of regulatory T cells? They inhibit T and B cells. Inhibit means to stop, guys. Okay? Now, what's another word for CD4 cell? T helper cell. What's another word for CD4 cell? T helper cell. What's another word for CD8? Cytotoxic T cell. What's another word for CD8? Cytotoxic. What is the name of the chemical, the cytokine, that allows for communication between leukocytes, interleukins. Which one interferes with viral replication? Interferons. What allows for communication between leukocytes? Interleukins. What allows for communication between white blood cells? Interleukins. Remember, another word for leukin is leukocyte, which means white blood cell. So whether I say leukins or white blood cells, you're fine. What interferes with viral replication? Interferons. What stops viral replication in our cells? Interferons. What is the name of the cytokine that stops the growth of a tumor? Tumor necrosis factor. What is the name of the chemical that stops the growth of a tumor? Tumor necrosis factor. Do B cells produce antibodies? Bad question. B cells, do they become plasma cells? Yes. Do plasma cells produce antibodies? Yes. Are antibodies proteins or proteins? Proteins. Are antibodies proteins or proteins? Proteins. So do antibodies actually kill? No. Can cytotoxic T cells kill? Yes. Can cytotoxic T cells kill? Yes. Can B cells kill? No. Can plasma cells kill? No. Can antibodies kill? No. Right here, do helper T cells secrete chemicals that sensitizes a B cell? Yes. Do T helper cells sensitize a B cell? Yes. What type of MHC does a B cell have? Type 2. What does a B cell have? Type 2. What does B cell have? Type 2. Okay. Do helper T cells sensitize B cells? Yes. Do they activate B cells? Yes. So sensitization and activation is the same word. Okay. I mean, I know it's different words in reality, but here in immunology it's the same thing. So, what cell is responsible for sensitizing B cells? Helper T cells. What cell is responsible for stimulating B cells? T helper cells. Okay? What cell, here's a question, I want you to listen to the answer choices. What cell is responsible for sensitizing or activating a B cell? I'm going to give you choices. A CD8 cell or a CD4? The answer is CD4. Because remember, CD4 is also known as a T helper cell. Okay? So even though it's CD4 is the antigen on the surface, a lot of people refer to CD4 cells as T helper cells. And cytotoxic T cells as CD8 cells. Do cytotoxic T cells kill? Yes. Do T helper cells sensitize B cells? Yes.